Okay, what's up guys? So today we'll be starting a new chapter which is inverse trigonometric functions. It's chapter 2 in any textbook of 12th grade. It's a very important chapter and is often confusing. But it's a chapter full of tricks. So in this video we'll be only discussing about the tricks, especially how to memorize a particular formula or how to draw different type of graphs. Okay, let's quickly jump to the action. So before we start, there are a few points to remember. First is sine inverse x should not be confused with sine x raised to the power minus 1. As you see here, power is minus 1, but this becomes 1 by sine x, and which is also equal to cosec x. So this is a wrong notation. I mean, it only happens in real numbers. If you have something like a raised to the power minus 1, we can write it as 1 by a. So this is only applicable when a is a real number, not for trigonometric functions. So don't confuse by seeing the power as minus 1. It is not reciprocal. Okay, it's a completely new function. That comes to the second point. Second point is that inverse trigonometric functions, they represent angles. Every inverse trigonometric function will represent an angle. Suppose sine inverse x function is there. So the job of sine inverse x function is to report the angle corresponding to a value which is thrown into the function. For example, so if I throw in value as half, then the corresponding angle is pi by 6, so that will be the output. Similarly, for cos inverse x function, if I throw in half, then value will be pi by 3, which will be reported in this. Next important point is that all these functions, sine inverse x, cos inverse x, tan inverse x, cot inverse x, cosec inverse x, sec inverse x, they are called inverse circular functions, or they are also called as inverse trigonometric functions. They are also sometimes represented by arc sine x. So don't get confused when you see this type of terminology, arc sine x or arc cos x. The meaning is the same. They are all representing inverse trigonometric functions. Now another important point, which is a prerequisite for this chapter, is having the knowledge of inverse functions. So as we discussed in the previous chapter, in the functions chapter, that inverse is only possible when the function is bijective. So what is bijective? Bijective is a combination of 1-1 function as well as onto function. Just to give you a brief about 1-1 function, so when you see a 1-to-1 correspondence from x to y, like we see here in this arrow diagram, then we call the function as 1-1 function. And the function is said to be onto if none of the elements are left unassociated in set B. Okay, this is very important. So you see this function which is on the right side is an onto function because none of the element is left unassociated in set B. Other name for 1-1 function is injective function. The other name for onto function is surjective function, and together when we put both of them, the function is called bijective function. Okay, so this term is very important. Please remember it. The function is bijective, then only we can take its inverse. Means bijective means, please repeat after me, bijective means 1-1 as well as onto function. Okay, this concept is very important and we'll be referring to this in this entire chapter at many places. Now let's talk about the graphs of inverse trigonometric functions. The graphs are particularly very interesting, and if you understand the graphs clearly, then you will be able to solve any question of inverse trigonometric functions. So here I'll be discussing primarily 6 graphs. Out of these, we'll be drawing the first 4 graphs, and the last 2 are DIY for you. I'm going to tell you a trick, and I want you to try that trick in the next 2 graphs. The name of the trick is rotate flip method. So we are going to do 2 things. One, we are going to rotate the graph. Second, we are going to flip the graph. Okay, this is very important. The order is important. First we'll rotate and then we'll flip. Rotate, flip, rotate, flip, rotate, flip. That's what we are going to do. I'm going to demonstrate this trick using sine inverse x graph. So in order to draw the graph of sine inverse x, we need to choose the base function sine x. Now sine x function I take in the interval from minus pi by 2 to pi by 2. Okay, you see here, this is the base function, sine x function. The graph is from minus pi by 2 to plus pi by 2 only, and the range is from minus 1 to 1. So this is the normal sine x function. Now in order to apply the trick, what was the first thing which I said? Rotate the graph. So we are going to rotate the graph in the anti-clockwise direction. So if I rotate the graph in the anticlockwise direction, watch carefully, something like this will happen. See, the graph got rotated in the anticlockwise direction. Next, once you rotate the graph, your graph will look something like this. The next step is we are going to flip this graph. Why flipping is important? Because if you observe carefully, on the right side we have -1 and on the left side we have +1. This is not acceptable. On the number line, all the negative numbers are on the left side and all the positive numbers are on the right side. So we need to flip the graph. When we flip this graph, then we will see that this number line will get corrected. So I am going to flip this graph, watch carefully. Isn't it cool? Now you see the final graph looks something like this. So I have done two steps. First is to rotate the graph and second is to flip the graph. Only two steps, rotate and flip. So this is the final graph of sine inverse x. Now I would also like to highlight here that in case of sine x, what is the range of sine x? Range of sine x is from -1 to 1. The maximum value of sine x function is 1, minimum value is -1. Okay. If you observe the sine inverse x graph, the domain is from -1 to 1. Domain is always the x axis. So you see the x axis is from -1 to 1 here. So can I say that the domain of an inverse function is same as range of a normal function? Yes, do you agree? See here. So this is -1 to 1 and this is also -1 to 1. They both are same. In terms of the range of inverse function, while the range of the normal function was from -1 to 1, the range of inverse function is from -π/2 to +π/2, as you can see in the graph. So remember this is very important. I will also tell you a trick how to memorize these range and domain values later. In terms of the properties of sine inverse x, let's take a moment to understand the properties of sine inverse x. As I told you, the domain of sine inverse x is from -1 to 1. The range of sine inverse x is from -π/2 to π/2. Domain is always x axis and range is always y axis. Remember that. Okay. Second thing is that all these inverse trigonometric functions are non-periodic functions. You see, this graph is only limited in this interval. Only this box is inverse trigonometric function. There is nothing outside this box. While we know that sin x function is a periodic function, there are curves like this, it continues till infinity. Inverse trigonometric functions is only contained in a small interval. There is nothing outside it, because we simply cannot substitute any value which is greater than 1 in the domain. We cannot substitute any value which is less than -1 in the domain. So that's why the graph is contained only in this small box. These functions are continuous function. This function is continuous function in -1 to 1. It's a differentiable function in open interval -1 to 1. I'm going to tell you another method to draw the graph of the function. So first trick that I told you is rotate and flip method. There is another method which is more popular and which is given in almost every textbook, which is using the properties of inverse. Inverse function and its base function are always symmetrical about y equal to x line. Let's see in the diagram here. The normal function, which is from -1 to 1, -π/2 to +π/2, will look something like this. This is the dotted line. If you observe here the dotted line, this dotted line is the graph of sine x. This dotted line is the graph of sine x. Yes, I am highlighting it in red color like this. And the inverse function, if I want to draw, what I will do is first I will draw the line y equal to x. First I will draw the line y equal to x and I draw a symmetrical figure to this particular line. So this highlighted line will represent the graph of inverse function. So as you can see, the graphs are matching on both sides. This graph and this graph are same. They are both representing the same thing. The only difference here is that this is drawn using the property of inverse function, which is the normal function and the inverse function are symmetrical about y equal to x line, whereas we have drawn this graph using rotate and flip method. Next, let's apply the same formula, same trick on another graph, and let's try to draw the graph of cos inverse x. Now, in order to draw the graph of cos inverse x, we are going to start from the base function cos x. Now, I am going to take cos x function in the interval 0 to pi. Okay. We all know that the graph of cos x functions looks something like this in 0 to pi interval. This point is pi by 2 because cos pi by 2 is 0. This is the graph. Now, I am going to rotate this graph. You see how cool the animation is. Yes, you saw the rotation. So, again I will show you. So, you see I am going to rotate this graph in the anti-clockwise direction by 90 degree. Right. So, the finished product will look something like this. Then next step is to flip the graph. So, again the problem is that -1 is on this side and +1 is on this side. Now, we are going to flip this graph again. So, when you flip the graph, this is the final graph that we will get. This is y equal to cos inverse x function. Again, I would like to highlight here that the range of cos x function is from -1 to 1. The domain of cos inverse x will also be -1 to 1. Whatever is the range of the normal function becomes the domain of inverse function. Again, let's highlight the properties of cos inverse x function. So, what we have seen from the graph, what all we can observe from the graph is that domain is from -1 to 1 and the range is from 0 to pi. Okay, that is the interval in which cos inverse x function is defined. Again, is it a periodic function? No, because there is no graph outside this box, only this graph in this box is the graph. So, this is the final graph which will look something like this. It is also a continuous function and it is also differentiable in -1 to 1. One more thing which you can observe is that it is a decreasing function. We can also use an alternative method, which is by drawing the graph, by drawing a graph symmetrical to y equal to x line. So, first I am drawing y equal to x line like this. This is y equal to x line, and then we are drawing the symmetrical graph to this. So, we will get exactly the same shape that we got earlier. I find this symmetry, finding out symmetry line and drawing the graph sometimes could be confusing. It depends on where this line is intersecting the curve. Okay, that is why I prefer rotate and flip method. So, till now we have seen the graph of sine inverse x and cos inverse x function. Now, why not tan inverse x? Let us try on tan inverse x. Let us apply the same trick. So, what is the name of the trick? Rotate and flip method. So, for tan inverse x, the base function is tan x. So, we will start with tan x function. I am going to take tan x function in the interval -pi by 2 to +pi by 2. When I rotate the graph looks something like this. You observe that pi by 2 is now in the positive y axis and -pi by 2 is in negative y axis, which is what we want. But the problem is that on this side we are getting positive infinity and on this side we are getting negative infinity. How to fix that? Easy, flip. So, now we are going to flip the graph. So, this is the final graph that we will get. Again, I am highlighting here that the domain of tan x is equal to range of tan inverse x. Range of tan x is equal to domain of tan inverse x. They both interchange the values. Just to summarize the properties of tan inverse x, the domain is from R -infinity to +infinity. The range is from -pi by 2 to pi by 2. It is open interval -pi by 2 to pi by 2. Okay, as shown in the graph. That is why we are drawing with dotted lines here. It is again a non-periodic function. Yes, the graph is only contained between these lines. There is nothing else outside this graph. It is a continuous function. It is a differentiable function. We also know the differentiation of tan inverse x. Yes, differentiation of tan inverse x will be 1/1 plus x square for x belonging to R. This is an increasing function as demonstrated in the graph. Again, I am showing you the alternative method for the same. So, you can also draw this graph using y equal to x line symmetry method. Now is the time for DIY. So, I want you to pause this video now and take pen and paper and try to draw the graph of cot inverse x using rotate and flip method. I am going to give you the base graph, which is cot x. So cot x is defined in the interval 0 to pi and the range is r. So this is the base function. Now try rotating this graph and then flip it. So I hope you have already tried the graph. Let me draw for you. So when I rotate this graph in the anti-clockwise direction like this, on the y-axis we'll have two dotted lines. 0 will come here, pi will come here, and the graph, it's rotated, so we'll get something like this. And then when you flip it, the graph will look something like this. So 0 here, pi here. So this is the graph of cot inverse x. Easy? So on your screen you can see the final answer. Please match with your answer. I hope you got the trick. Please try the same trick for cosec inverse x and sec inverse x also. All you have to do is just start from the base graph of cosec x and sec x and then rotate and flip. I am going to give you the base graph. Please try yourself. So here is the base graph for cosec x. Please try to rotate and flip this graph. If you got the answer, please comment. Let me know whether the trick is helpful to you or not. Yes, you already know the base graphs in your textbook. Try to match it with the graph which I have given to you. Also, this trick is not just applicable to the trigonometric functions. You can apply for any inverse function. Suppose e raised to the power x function is given to us and I want to draw the graph of the inverse function for that. I can apply the same trick, rotate and flip to get the graph of the inverse function. So this trick is universal in nature. You can apply for any function whose inverse needs to be found. Now we have solved the big problem, that is to draw the graphs of inverse function. Now the another challenge is to memorize the domain and range values. So I have one trick for that also. So I have given you two tables here. You can see on the screen. This is the table for domain and range of the inverse trigonometric functions, and on the right side we have domain and range for the normal functions. Now the trick is that domain of inverse trigonometric functions is equal to range of trigonometric function. Yes, you heard it right. Domain of inverse trigonometric functions is same as range of normal trigonometric functions. So if I want to find the domain of sine inverse x, I will try to think what is the range of sine x. Now we are done with the domain part. Next is the range. A simple trick to memorize range is, remember the word sitaco. S-I-T-A-C-O, sitaco. What is sitaco? So SI means sine, TA means tan, CO means cosec. Okay. So if you see in the table, sine inverse x range is from minus pi by 2 pi by 2, tan inverse x from minus pi by 2 pi by 2, cosec inverse x is from minus pi by 2 pi by 2 minus 0. You see all the three functions, sine inverse x, tan inverse x, cosec inverse x, they all have same range, minus pi by 2 to pi by 2. Now what about the other three? Yes, other three also follow the same pattern. Like cos inverse x, if you see the range of cos inverse x, it's 0 to pi. Similarly, if you see the range of sec inverse x, it's also from 0 to pi, minus pi by 2, and cot inverse x is also 0 to pi. So in this entire chapter, sine inverse x, tan inverse x and cosec inverse x, they all three follow similar properties. It becomes very easy. If you know the format for one, you can write the format for others. Alright. So remember the trick, sitaco. So Sita ko yaad karo, she will save you. Let's take an example here. So I am taking an example from the CBSE book. It's exercise 2.1. We have to find the principal value branch for each of the function. First function is sine inverse of minus half. Here the steps are important. You have to write the correct statement. So first you write let sine inverse minus half is equal to theta, so that sine theta becomes equal to minus half. Since the principal value branch of sine inverse x is from minus pi by 2 to pi by 2, think of a value which will give us minus half. So yes, you guessed it correct. The value is minus pi by 6. So you can directly write the answer. This is usually a 1 mark question which is asked in the exams. So please pay attention. This type of question is sure to come in any of the exams that you will write, whether it's a mock test or it's an actual exam. So please try the same on the following examples which are given here, and let me know in the comments whether you got all the answers or not. You can match the answers from the CBSE textbook exercise 2.1. Alright, thank you for watching this video. I hope it helped you in understanding the topic better. Please apply the tricks and share as much as possible. Alright, also please like and subscribe our video. Thank you very much.